All solar cells have the same basic job: convert solar energy into electricity as efficiently and reliably as possible. Day4 Energy has an innovative approach to designing a more effective cell front side: Stay Powerful technology. Traditional solar cells are manufactured by exposing very thin wafers of treated crystalline silicon to various chemical and thermal processes, and then applying an anti-reflective coating to the front of the cell. When particles of light, photons, hit the solar cell, energy is transferred to electrons in the silicon cell, allowing them to move about freely. A pathway must then be created to an external circuit so that electrons can be delivered as electricity to power things like lights and household appliances. On a conventional cell, this is done by printing a grid of silver wires called fingers on the cell front that are then interconnected by 2 to 3 thicker pads known as bus bars. In order to form an electrical contact between the fingers and the treated silicon material, the cells must be heated or fired to over 800 degrees Celsius. This traditional method creates 3 major challenges. One is that the thick fingers and bus bars typical of conventional solar cells increase the amount of shade on the cell's surface, reducing the amount of light collected and converted into energy. 2. Copper wires, called ribbons, that conduct electrical current from cell to cell must be soldered to the bus bars. This process can create cell breakage due to high soldering or welding temperatures and mechanical stress. And 3. Traditional solar cells make extensive use of silver particulates within their fingers and bus bars, reducing their efficiency. Our technology is different, more advanced, and the result is more energy. It's in our DNA. Let's take a closer look. To begin with, we've changed the bus bar architecture. We eliminated those thick, inefficient bus bars made of silver paste. We've also eliminated the need for high-temperature soldering by connecting our cells with many electrically efficient copper wires coated with a custom-made low-melting point alloy. These special wires are partially embedded into a thin layer of adhesive that is placed into a polymeric film with one external bus bar along the end. Next, the layers are laminated and vacuum sandwiched together at a low temperature. This reduces the potential brittleness of the cell. With many wires replacing the 2 bus bars, the transportation of electrons to a highly conductive contact is achieved more effectively with less resistance and heat generation. And with fewer silver particulates, greater harvesting and lower light conditions is possible when the intensity of energy from the sun is reduced. Finally, the matrix effect of our Stay Powerful technology creates at least 18 times more interconnection points than a standard cell, so if a microcrack normally associated with the traditional bus bar architecture does occur, the electron flow is not interrupted. Day4 Energy. Advanced technology. More energy. It's in our DNA.